Hi, good afternoon. I'm Stephen Clark. I'm the Principal Advisor, Digital Engineering for Transport at NZTA. I'm here to show everybody the asset management data standards, or what some of my colleagues call it, the wavy flowers, because when I do a little shiggle, they wave around. What this actually demonstrates, though, is an underlying data model, which is what we are trying to get across to our stakeholders to be able to make New Zealand a better, safer and more sustainable country. Currently, New Zealand Transport Authority dishes out $5.3 billion, roughly half on maintenance and half on capital build. Currently, there's 63 different local authorities that spend that money and around about 24 alliances that do the state highways. They all do the data capture slightly differently, which is a challenge for us because we want to get a national view. So how do we get a national view? We create an underlying data standard. What is a data standard? Well, it's a data model built on an ontology of semantic thinking, which allows us to design entity models down into data models so that we can have consistency right across the system. Ultimately, the whole world, in the physical sense, should be related as a digital twin in order to make decisions. That's what we're trying to do. What tends to happen with subject matter experts is they try to duplicate the real world in data systems. Now we have to abstract it away so we can represent their view, but the view of others, the decision makers, the financial decision makers, the people that want to view that for historical purposes, they want to view people that want to view it for cultural purposes. The government, local government, everyone has a different view and a different reason to look at that information, but it should only be created once and used many times. So the purpose of the asset management data system is to allow us to have a consistent interoperable data set for the whole of New Zealand for all land transport assets. Now the reason that we have a digital twin or a digital domain for anything really is so that we can make decisions in the real world and have a digital twin that represents that physical world in a way that can inform a decision maker. As I alluded to before, often what happens is subject matter experts are so close to their subject that they try and replicate the real world in the digital domain, when actually you need to abstract it away so that it can be represented in a number of different views for a number of different stakeholders and users. Without a data standard, every data exchange is complex and difficult. We want to make that simple, efficient, and easy to do. And it has to be human readable, but the real guts of it has to be done machine to machine. So the design, I'll skip past this, but really there's 3 levels of compliance to this. Just to get a common language would be quite a win for New Zealand, everybody calling things the same things. Before we move to the common concepts, to move to the all singing, all dancing ontological schema view base of the world. So what's the problem? The problem is that when we try and bring data sets across from those 100 stakeholders across New Zealand that spend money on our behalf under the Land Transport Act, they do it slightly differently. And when you try and bring data sets together, you can't do it, or not meaningfully. And what ends up happening is you do the best that you can, but you're not comparing apples with apples. You have to make concessions, you have to make decisions about what you put through. You lose the provenance of the data, and you'll lose the accuracy of the data, and some poor person has to do an awful lot of physical labour to make that happen. Who are we working for? Is the data working for us, or are we working for the data? Hard to tell sometimes. So what we want to do is move to an ontological view of the world. We know that attributes and values exist at multiple levels, so what do? Currently, we duplicate them, they get out of whack if they were even consistent in the first place. So why not bring them together into one underlying model? We do that from having an underlying data dictionary that can be brought dynamically together depending on the context. So we have consistency of data right across the system and regardless of the context. To do that, we have to have a high-level generic view of the world, which is our data concept model. Then we have to have the technical specifications, which allow us to bring it down a level to what can be implemented in a system. Because our standard not only has to be implementable, it has to be implemented. So we have our entity model. For the geeks out there, this is based on TOGAF 9. We've done some jiggery pokery. But really what it's expressed as to make a very, very simple view of the world is incredibly difficult, so we hide all the complexity away in those models, and this is what you see, a data dictionary that populates value lists that we can attribute a value and a descriptor to an attribute which relates to an entity type. That's the data view of the world. So what does that mean for the user at the level that they want to use it at? Because I've spoken about ontological models, highfalutin concepts. Hey, I just want to do my job. How do I help our users do their job? Well, we design the data model so that it reflects what users need in a way that's meaningful for them. So if I just take that particular asset type, that's pavement layer, you can see if you need a photograph to know where it is, there it is. If you want to know just the elements that relate to that object, you can do that. We're starting to build it. It's not fully built at the moment, but as you can see, we can start to bring searchable terms in, all the different terms that might be related, so that when you search for widget A, widget B, widget C, if it's the same thing but it's named differently across the business, the ontology can bring that together. We can also add business rules to be able to automate business processes or to automate data capture. And to automate that data capture, we need to have maximum minimum values, SI units, and that kind of thing to get consistency across it, and to stop data quality at the front end, not get the ambulance at the bottom of the cliff. Where we need a reference document or a schematic, we can add that in as well. And from our users, if they want to comment on that and give us their views and how we can change it to make it better, they can add their views in there. Now, what does that mean on a day-to-day basis? Well, there I can see what is being described, but actually I just want to put this into my system and get on with my job. So what I can do then is I can go to the filter settings, filter the objects relevant to my context that I need, and then I can push this button here. So I'm Joe and Gore running an asset management data system, and I just want the stuff that I need to do my job. There you go, mate. How do you want it? Do you want it in XLS? Do you want it in CSV? Do you want it in SQL? Do you want it in JSON? We'll help you to put it into your asset management system or your SAP system or your EDRMS system through, if we need to, ETL. We can do it system to system, or we can export the schema to you in a way that you can consume within your organization according to the system as you need it. So as I spoke about not only being implemented, it has to be implementable. In order to be implemented, that's how we make it real. We're not going to give you a PDF bit of shelfware. We're going to give you a data model that you can use in your day-to-day systems every day to do your job, make it more efficient, easier for you, more automated for you, take the effort from you. And what do we get? We get a national view to allow government to make macro decisions on the future of New Zealand and how we spend and make our beautiful country a happier, safer, more resilient and more environmentally safe country.